Picture a world where mountains grow taller while you sleep, where the ground beneath your feet drifts slowly across an ocean of molten rock, and where every breath you take connects you to forests thousands of miles away. That world is not a fantasy. It is Earth. Tonight we rest together on our home planet. There is no test at the end, no hurry, no urgency. Just the gentle unfolding of wonders about the only place in the known universe where life has taken root. The universe may be vast beyond measure, but tonight we stay close to home. We explore the blue marble spinning quietly through the dark. Mountains that pierce the sky, oceans deeper than any canyon, creatures that glow in the abyss, plants that communicate through underground networks, and forces so powerful they reshape continents over millions of years. All of this waiting to be whispered into the stillness. Tonight, let's drift off together while exploring 100 soothing facts about our extraordinary home. There's no rush here, no test at the end. Just soft words and quiet wonders to carry you into rest. Welcome to Drowsy Discovery. I'm glad you found your way here tonight. Perhaps you've had a long day. Or maybe you simply enjoy falling asleep to thoughts bigger than tomorrow. Either way, this journey is for you. There is something deeply calming about contemplating our planet. It is vast enough to humble us, yet familiar enough to feel like home. Every river, every forest, every grain of sand has a story that stretches back millions of years. So settle in. Let your breathing slow, and let the weight of the day drift away, like clouds across a quiet sky. Earth is the third planet from the Sun, a rocky world wrapped in thin layers of water and air. It hangs in the darkness of space, spinning gently, orbiting a star that has burned for nearly 5 billion years. And on this world, something remarkable has happened. Life. As far as we know, Earth is the only place where life exists. The only world where creatures breathe and grow and dream. Tonight, we will wander through the hidden depths of our planet. We will explore the forces that shape its surface. We will meet creatures that defy imagination. And we will discover truths about our home that may surprise even the most curious minds. But there is no hurry. The Earth has been spinning for 4.5 billion years. It can wait a little longer while you rest. Let us begin with the very ground beneath your feet. The Earth is not solid all the way through. Beneath the thin crust we live on lies a layer of hot, slowly flowing rock called the mantle. And at the very center, a core of iron and nickel burns, at temperatures hotter than the surface of the Sun. The inner core alone is nearly as hot as 6,000 degrees Celsius. Yet it remains solid, held together by immense pressure from the weight of the planet above. This heat is not left over from Earth's formation. Much of it comes from the slow decay of radioactive elements deep within the rock. The planet generates its own warmth, a quiet furnace that has been burning for billions of years. And this heat drives everything. It moves the continents. It builds mountains. It opens rifts in the ocean floor. The Earth is alive in ways we rarely consider. The crust you walk on is remarkably thin. If Earth were the size of an apple, the crust would be thinner than the apple's skin, barely a scratch on the surface of a much larger world. And yet this thin layer is where all life exists. Every tree, every animal, every city, every ocean, all of it rests on a shell of rock, floating atop a sea of molten mantle. The crust is not one solid piece. It is broken into massive slabs, called tectonic plates. These plates float slowly on the mantle beneath, drifting at roughly the speed your fingernails grow, about 2 to 10 centimeters per year. It seems slow, almost imperceptible. But over millions of years, this motion reshapes the entire surface of the planet. Continents collide, mountains rise, oceans open and close. The map, you know, is only a snapshot in time, a fleeting arrangement that has changed countless times before and will change countless times again. 250 million years ago, all of Earth's continents were joined together in a single supercontinent called Pangaea, one vast landmass surrounded by one vast ocean. If you could have walked across it, you might have traveled from what is now Antarctica to what is now Siberia without ever crossing water. But Pangaea did not last. The forces beneath the surface pulled it apart. Rifts opened, seas flooded in. And slowly, over tens of millions of years, the continents drifted to their current positions. And they are still moving. The Atlantic Ocean grows wider by about 2.5 centimeters every year. The Pacific Ocean is shrinking. Africa is slowly splitting in two along the East African Rift, and Australia is drifting northward toward Asia. The world map is not finished. It is still being drawn. When tectonic plates collide, something must give. Sometimes one plate slides beneath another. In a process called subduction, the descending plate melts back into the mantle, and volcanoes form above. This is why the Pacific Ocean is ringed with fire, a chain of volcanoes, stretching from Chile to Japan. But sometimes neither plate wants to sink. When two continental plates collide head-on, the crust crumples and folds. Rock is pushed upward into towering peaks. This is how the Himalayas formed. The Indian subcontinent, once an island drifting north, crashed into Asia roughly 50 million years ago. The collision has never stopped. India is still pushing northward, and the Himalayas are still rising. Mount Everest grows taller by about 4 millimeters every year. The highest point on Earth is still being built. But the mountains do not only rise, they also fall. Erosion wears them down. Rain and wind and ice slowly carve away the rock. Rivers carry sediment to the sea. Glaciers grind stone into powder. Over millions of years, even the mightiest peaks are reduced to hills, and then to plains, and then to nothing at all. The Appalachian Mountains in eastern North America were once as tall as the Himalayas, perhaps taller. 400 million years ago, they towered over the landscape. Now they are gentle, rolling ridges, worn down by time, softened by the patient work of water and weather. The mountains you see today are just a moment, a pause between rising and falling, a glimpse of forces that never rest. Beneath the oceans lies a hidden world, of mountains, valleys, and volcanic ridges. The mid-ocean ridges are the longest mountain chains on Earth. They stretch for over 65,000 kilometers across the ocean floor, longer than the Himalayas, the Andes, and the Rockies combined. At these ridges, tectonic plates pull apart. Magma rises from the mantle and cools into new ocean floor. The sea floor spreads outward from the ridge, carrying the history of Earth's magnetic field, frozen into the rock. Every few 100,000 years, Earth's magnetic field flips. North becomes south, south becomes north. And the record of these reversals is written in the iron minerals of the ocean floor, like a barcode stretching across the seabed. We do not fully understand why the field reverses, but we know it has happened hundreds of times, and it will happen again. The magnetic field that surrounds Earth is not just a curiosity. It is essential for life. Generated by the churning of molten iron in the outer core, the magnetic field extends far into space. It creates a protective bubble called the magnetosphere. This invisible shield deflects the solar wind, a stream of charged particles constantly blasting outward from the sun. Without the magnetosphere, these particles would strip away our atmosphere. They would bombard the surface with radiation. Mars once had a magnetic field, but it faded billions of years ago. And without that protection, the solar wind slowly tore away the Martian atmosphere. Today, Mars is cold and barren. Earth's magnetic field is the reason our skies are blue, the reason our oceans still exist, the reason life was able to flourish. A quiet guardian spinning in the liquid iron at our planet's heart. Sometimes the particles from the sun find a way in, near the poles, where the magnetic field lines converge. Charged particles from the solar wind spiral downward into the atmosphere. They collide with oxygen and nitrogen molecules, exciting them into glowing displays of light, green and red and purple, curtains of color rippling across the night sky. The aurora borealis in the north, the aurora australis in the south. These lights are not reflected, they are not refracted. They are created in the upper atmosphere, 100 kilometers above the ground. The air itself is glowing. And though they seem magical, they are simply physics. Energy from the sun, channeled by Earth's magnetic field, transformed into light. A reminder that our planet is not isolated. It is connected to the star that gives it life. Now let us descend into the depths. The ocean covers more than 70% of Earth's surface. It contains 97% of all the water on the planet. And yet, we have explored less of it than we have explored the surface of the moon. The average depth of the ocean is about 3,700 meters. Deep enough to swallow most mountains. Deep enough to hide entire worlds. In the deepest place on Earth, the Challenger Deep, in the Mariana Trench, the ocean floor lies nearly 11,000 meters below the surface. The pressure at that depth is crushing. Over 1,000 times the pressure at the surface. The weight of the entire ocean pressing down. And yet, life exists there. Strange creatures, adapted to eternal darkness and immense pressure. Amphipods the size of rabbits, fish with translucent bodies, organisms that have never seen the sun. Life finds a way. Even in the most extreme places on Earth, the ocean is not just deep, it is also old. The oldest water in the ocean has been circulating for over 1,000 years. It sinks in the polar regions, where cold, salty water is dense and heavy. It flows along the ocean floor, creeping toward the equator, rising again in distant seas. This slow circulation is called the thermohaline conveyor. It moves heat around the planet. It distributes nutrients. It connects every ocean into one continuous body of water. A single drop of water might travel the entire globe before returning to where it started. The ocean is not still. It is a planet-wide river, flowing in 3 dimensions, through time, and the ocean holds secrets we are only beginning to understand. In the 1970s, scientists discovered hydrothermal vents on the ocean floor, places where superheated water, rich with minerals, gushes from cracks in the crust. The water around these vents can reach 400 degrees Celsius. It should boil, but the pressure is so intense that it stays liquid. And surrounding these vents, life thrives. Giant tube worms, ghostly white crabs, shrimp with eyes that sense infrared light. Entire ecosystems sustained not by sunlight, but by chemistry. The bacteria at these vents convert hydrogen sulfide into energy through a process called chemosynthesis. They are the foundation of a food web that exists in total darkness. Some scientists believe life on Earth may have begun at hydrothermal vents, deep in the ocean, far from the sun, where chemistry first became biology. If this is true, then the darkness of the deep sea is not just a strange corner of our planet, it is the birthplace of everything. Let us rise now from the depths and consider the water that falls from the sky. Rain. A single raindrop begins as water vapor rising from the ocean. Warmed by the sun, it evaporates into the atmosphere. It drifts on currents of air. It cools. It condenses around tiny particles of dust or pollen. And eventually, it falls. The average raindrop travels about 10 minutes from cloud to ground. In that brief journey, it may travel miles horizontally, carried by the wind. And when it lands, its journey is not over. Some raindrops soak into the soil, others flow into streams. Some evaporate again, almost immediately. A single water molecule might cycle through the atmosphere, the ocean, and the land dozens of times before settling anywhere for long. The water you drink today may have fallen as rain in a distant century. It may have flowed through ancient rivers. It may have been part of glaciers that covered continents during the ice ages. Water is never created or destroyed on Earth. It simply moves, endlessly cycling through the planet's systems. The same water that dinosaurs drank. The same water that will sustain generations not yet born. Speaking of ice ages, let us consider how the climate has changed. Earth has experienced at least 5 major ice ages in its history. Periods when vast ice sheets covered much of the planet, when glaciers carved valleys and sea levels dropped by hundreds of meters. The most recent ice age peaked about 20,000 years ago. Ice covered Canada, northern Europe, and much of Russia. The glaciers were so thick, some reached 3 kilometers high. So much water was locked in ice that the sea level was over 100 meters lower than today. Land bridges connected continents. Humans walked from Asia to North America, from Europe to Britain, and then the climate warmed. The ice retreated. The seas rose. The world we know today slowly emerged. But the ice ages are not over. We are living in an interglacial period, a warm interval between glacial advances. The ice will likely return in 10,000 years, or 100,000, or perhaps longer, if human activity continues to warm the planet. The climate is always changing, but the pace of that change matters. The atmosphere is remarkably thin. If Earth were the size of a basketball, the atmosphere would be thinner than a sheet of paper wrapped around it, a fragile envelope of gas separating us from the vacuum of space. Most of the atmosphere lies within the first 10 kilometers above the surface. The summit of Everest is already at the edge of breathable air. Aeroplanes fly at the boundary of survivability. And beyond 10 kilometers, the air grows thinner and colder. At the edge of space, roughly 100 kilometers up, there is almost nothing left. This thin layer is all that protects us from cosmic radiation, all that traps the warmth of the sun, all that allows water to exist as liquid on the surface. We live at the bottom of an ocean of air, and we rarely notice it at all. The atmosphere is mostly nitrogen, about 78%. Oxygen makes up about 21%. And the remaining 1% includes argon, carbon dioxide, water vapor, and trace gases. But that small fraction of carbon dioxide is extraordinarily important. Carbon dioxide traps heat. It absorbs infrared radiation from the Earth's surface and re-emits it back downward. This is the greenhouse effect. Without greenhouse gases, Earth would be frozen. The average temperature would be about -18 degrees Celsius. Life as we know it would be impossible. But with too much carbon dioxide, the planet warms. Ice melts, seas rise, weather patterns shift. the delicate balance that allows life to flourish begins to tip. The atmosphere is a thermostat, and the settings matter. Let us now consider the living world. Earth is home to an estimated 8 to 10 million species, perhaps more. Many have never been discovered. Many never will be. From bacteria, too small to see, to whales, longer than any dinosaur. From fungi that spread for miles underground, to birds that migrate across hemispheres. Life has filled every available niche. It lives in the frozen Antarctic, in boiling hot springs, in the acidic depths of mines, in the clouds, in the soil, in the bodies of other organisms. Life is not delicate. It is persistent, adaptable, relentless. And it has been evolving for nearly 4 billion years. The first life on Earth was simple, single-celled organisms, drifting in ancient oceans. For over 1 billion years, nothing more complex existed. But slowly, life learned to cooperate. Cells joined together. They specialized. They formed tissues, then organs, then bodies. The first animals appeared about 600 million years ago. The first fish about 500 million years ago. The first land plants about 470 million years ago. Each step took millions of years. Each adaptation was tested by extinction. Only the successful survived. And then, about 250 million years ago, the greatest extinction in Earth's history nearly ended everything. The Permian extinction. Over 90% of marine species vanished. Over 70% of land species. The oceans became toxic. The atmosphere filled with carbon dioxide. Temperatures soared. We still do not fully understand what caused it. Massive volcanic eruptions in what is now Siberia may have triggered a cascade of disasters. Methane released from the seafloor may have accelerated the warming. Whatever the cause, life was nearly extinguished. The recovery took millions of years, but life did recover. It always does. And from the ashes of the Permian extinction, new lineages arose, including the ancestors of the dinosaurs. For over 160 million years, dinosaurs ruled the Earth. They were not slow and sluggish, as old books suggested. Many were fast. Some were warm-blooded. Some had feathers. Some cared for their young with surprising tenderness. They filled every ecological role: towering herbivores that stripped forests bare, swift predators with keen senses, armored giants that could withstand any attack. And then, 66 million years ago, a rock the size of a city fell from the sky. The asteroid struck what is now the Yucatan Peninsula in Mexico. It released energy equivalent to billions of nuclear bombs. It vaporized rock. It set forests ablaze across continents. It threw so much dust into the atmosphere that the sun was blocked for years. The dinosaurs, except for one lineage, were wiped out, along with 75% of all species on Earth. The one lineage that survived became the birds. Every sparrow, every eagle, every penguin is a living dinosaur. The descendants of creatures that once shook the ground. And in the aftermath of that extinction, small furry mammals emerged from the shadows. They diversified. They grew. They eventually became us. Let us now consider the forests. Forests cover about 30% of Earth's land surface. They are home to more than 80% of all terrestrial species. They produce oxygen. They absorb carbon dioxide. They regulate rainfall. A single large tree can release over 100,000 liters of water into the atmosphere each year through transpiration. When you stand in a forest, you are surrounded by invisible rivers flowing upward into the sky. Forests create their own weather. The Amazon rainforest generates much of its own rainfall. Moisture evaporates from the trees, rises, forms clouds, and falls again. A self-sustaining cycle of water and life. If the forest is destroyed, the cycle breaks. Rain becomes less frequent. Droughts intensify. The land dries. What was once jungle can become savanna or desert. And forests communicate. Beneath the soil lies a vast network of fungal threads called mycorrhizae. These threads connect the roots of different trees, forming what some scientists call the wood wide web. Through this network, trees share nutrients. They send chemical signals. They warn neighbors of insect attacks. Mother trees can recognize their offspring and channel resources to them through the fungal web. A forest is not a collection of individuals. It is a community, a superorganism connected by threads too thin to see. Let us now consider the creatures that share our planet. The blue whale is the largest animal that has ever lived. Larger than any dinosaur, larger than anything that has ever existed. An adult blue whale can reach 30 meters in length. Its heart is the size of a small car. Its tongue weighs as much as an elephant. Its arteries are so wide that a human child could swim through them. And yet, blue whales feed on some of the smallest creatures in the ocean. Krill, tiny shrimp-like animals that swarm in the cold waters. A blue whale can eat 4 million krill in a single day, over 3,000 kilograms. It opens its vast mouth, takes in a volume of water larger than its own body, and filters out the krill with plates of baleen. The largest feeds on the smallest. A reminder, that size is not always about what you eat. Sometimes it is about eating in extraordinary quantities. At the other end of the scale, the smallest vertebrate on Earth is a frog, smaller than a fingernail. Paedophryne amoensis, from Papua New Guinea, measures just 7.5 millimeters long. It was only discovered in 2012, hiding in the leaf litter of the rainforest, making high-pitched calls that scientists mistook for insects. There may be countless species like this, tiny, hidden, unknown. Every expedition into the deep forest or the deep ocean reveals new forms of life. The catalogue of Earth's creatures is far from complete. Some animals live for extraordinary lengths of time. The Greenland shark is one of the longest-lived vertebrates known. Some individuals may be over 500 years old. They were swimming in the Arctic when Shakespeare was writing his plays. They grow slowly. They mature slowly. A female Greenland shark may not reproduce until she is 150 years old. In the cold, dark waters of the North, time moves differently. Life stretches out. Patience becomes a strategy for survival. And then, there are the immortals. The jellyfish, Turritopsis dornea, has a remarkable ability. When injured, stressed, or simply old, it can revert to an earlier stage of its life cycle. Like a butterfly, turning back into a caterpillar, it returns to its polyp form and begins again. Theoretically, this process can repeat indefinitely. The immortal jellyfish is not immune to predators or disease, but it has found a way to reset its biological clock, to begin life anew. We do not fully understand how it does this, but it reminds us that biology holds secrets we have barely begun to uncover. Some creatures light up the darkness. Bioluminescence, the ability to produce light through chemical reactions, has evolved independently at least 50 times. Across the tree of life, fireflies flash patterns to attract mates. Deep-sea fish dangle glowing lures to attract prey. Jellyfish pulse with soft blue light. Fungi glow green in the rotting wood of forest floors. In the deep ocean, where sunlight never reaches, bioluminescence is everywhere. It is the primary source of light. The darkness is not truly dark. It is filled with living sparks. The chemistry is elegant. An enzyme called luciferase reacts with a molecule called luciferin, releasing energy as visible light. Cold light. No heat. Just glow. And humans cannot produce it. But we can witness it and wonder. Some creatures can survive conditions that would destroy almost any other form of life. Tardigrades, also called water bears, are microscopic animals less than a millimeter long. They look like tiny eight-legged bears, under a microscope. They can survive freezing temperatures close to absolute zero, boiling heat above 100 degrees, crushing pressure, intense radiation, and the vacuum of space. In 2007, scientists launched tardigrades into orbit. They returned alive. How do they do it? By entering a state called cryptobiosis. They dry themselves out almost completely and suspend their metabolism. They do not die. They wait, sometimes for decades. And when water returns, they reawaken, as if nothing happened. Tardigrades remind us that life is tougher than we ever imagined. Now let us consider the plants. Plants are not passive. They may not move quickly, but they respond. They adapt. They communicate. When a plant is attacked by insects, it can release chemicals into the air. These volatile compounds warn neighboring plants, which then boost their own defenses. They produce bitter chemicals. They toughen their leaves. They prepare for attack. It is not language as we understand it, but it is communication. Information passing from organism to organism through the air. Some plants can count. The Venus flytrap does not snap shut at the first touch. It waits. If a second trigger hair is touched within about 20 seconds, only then does it close. This counting mechanism prevents the trap from wasting energy on false alarms. Raindrops, debris, random vibrations. Only the movement of a real, active prey will trigger the response. A plant that measures, that calculates, that waits. And some plants are ancient, beyond imagination. There is a bristlecone pine in the White Mountains of California that has been alive for nearly 5,000 years. It was growing when the pyramids of Egypt were being built. It has survived droughts, fires, lightning strikes, the slow crawl of glaciers, and still it grows, twisted and weathered, but alive. Even older is a clonal colony of quaking aspens in Utah called Pando. Though individual trunks may die and regrow, the root system is estimated to be over 80,000 years old. One organism, spreading across 40 hectares, older than the last ice age, perhaps the oldest living thing on Earth. Let us now consider the smaller worlds within our world. Your body contains more microbial cells than human cells. Trillions of bacteria, viruses, fungi, and archaea live on your skin, in your mouth, and deep within your gut. This collection is called your microbiome, and it is not just along for the ride. It helps digest your food. It trains your immune system. It produces vitamins. It may even influence your mood and behavior. In many ways, you are not a single organism. You are an ecosystem, a walking community of countless species, all working together to keep you alive. The soil beneath your feet is similarly alive. A single gram of healthy soil can contain billions of bacteria, millions of fungi, thousands of protozoa, hundreds of nematodes, and countless other organisms. This microbial community breaks down organic matter. It releases nutrients. It helps plants grow. It filters water. It stores carbon. The soil is not dirt. It is one of the most complex ecosystems on Earth, and we have barely begun to understand it. Let us now consider the strange. There is a fungus in Oregon that may be the largest organism on Earth. Armillaria ostoyae spreads underground for over 2,000 acres. A vast network of mycelia, the thread-like structures that make up fungal bodies. It is estimated to be thousands of years old. Above ground, it occasionally produces mushrooms, but the real organism is hidden, a quiet giant beneath the forest floor. There are fish that can walk on land. The mudskipper uses its strong pectoral fins to crawl across mudflats and even climb trees. It breathes through its skin and the lining of its mouth, keeping itself moist to absorb oxygen. It is a glimpse of the past, a hint of how our ancestors may have first emerged from the sea. The boundary between water and land is not as sharp as it seems. There are birds that can fly while sleeping. The alpine swift can stay aloft for over 200 days without landing. It eats, drinks, and even sleeps on the wing. It achieves this through unihemispheric sleep. One half of the brain rests, while the other remains alert, controlling flight and avoiding obstacles. Rest and motion can coexist, even in the sky. There are animals that can survive being frozen solid. The wood frog of North America can survive having most of the water in its body turn to ice. Its heart stops, its blood freezes, its brain goes silent. But thanks to natural antifreeze compounds in its tissues, the frog's cells remain intact. When spring comes and temperatures rise, it thaws out and hops away as if nothing happened. It is not metaphor, it is cryogenic survival. A frog that defies winter itself. Let us now consider the forces that shape the land. Water is the most powerful sculptor on Earth. Rain carves valleys. Rivers shape canyons. Waves reshape coastlines. Ice grinds mountains into powder. The Grand Canyon was carved by the Colorado River over millions of years. Layer by layer, the rock was worn away, exposing nearly 2 billion years of geological history in its walls. Water is patient. It works slowly, but given enough time, it can move mountains. Wind, too, shapes the land. In deserts, wind carves rock into strange formations. Arches, pillars, mushroom shapes, balanced on slender stems. Sand dunes migrate across the landscape, driven by the wind. Some dunes can move tens of meters in a single year. The desert is not still, it flows. And then there are earthquakes. When tectonic plates suddenly slip past each other, the ground shakes. Buildings collapse. Tsunamis race across oceans. The landscape itself can shift. The energy released by a major earthquake can be equivalent to millions of tons of explosives. The ground can move several meters in seconds. And yet, earthquakes are simply the earth releasing stress. The same forces that build mountains also cause them to shake. Volcanoes, too, are expressions of the forces beneath. When magma reaches the surface, it erupts, sometimes gently, flowing lava, building shield volcanoes, like those in Hawaii, sometimes explosively, blasting ash and rock into the stratosphere. The eruption of Mount Tambora in 1815 ejected so much material into the atmosphere that the following year was called the year without a summer. Crops failed across the northern hemisphere. Snow fell in June. Volcanoes can cool the planet. They can also warm it, releasing carbon dioxide that lingers for millennia. They are vents, pressure valves, reminders that the Earth is not a quiet rock. It is a living, breathing system. Let us now wander into the world of animal intelligence. Elephants mourn their dead. When an elephant encounters the bones of a deceased relative or friend, it pauses. It touches the remains with its trunk. It lingers. Some have been observed returning to the same spot years later, gently examining the bones again. Elephants have even been seen standing guard over the dying, staying nearby, refusing to leave. Their grief may not be exactly like ours, but it is something deeply felt. They form strong family bonds. They remember old companions. And they seem to carry emotional weight across the years. It is a quiet truth that humbles us. Empathy, loss, and love may not belong only to humans. In the hearts of these great gentle giants, something very old and tender stirs. Crows can recognize human faces. These birds Members of the corvid family have been observed remembering the faces of people who have wronged them, and they hold grudges for years. In experiments, researchers wearing masks that had previously threatened crows were scolded by birds that had never personally encountered them. The information had been passed between generations. Crows use tools. They bend wires into hooks. They drop nuts in front of cars to crack them open. They plan for the future. Their intelligence rivals that of great apes, despite their much smaller brains. And unlike many animals, crows seem to think ahead, not just act on impulse. They are planners, problem solvers, quiet minds in feathered coats, watching, learning, and remembering. Dolphins have names for each other. In the ocean's shimmering blue, dolphins communicate with an intricate language of clicks and whistles. But there is something even more remarkable. They seem to have names. Each dolphin develops a unique signature whistle early in life, a kind of acoustic identification. Other dolphins learn and remember this whistle, using it to call out to specific individuals. When researchers played back a dolphin's own signature whistle, the animal responded just like a person might turn when hearing their name. This behavior suggests a level of social memory and identity previously thought to be uniquely human. Dolphins live in complex, ever-changing groups. Being able to identify and track individuals helps maintain bonds, manage relationships, and navigate their fluid social world. In the deep, dolphins speak. And in their calls, we glimpse something astonishing. The roots of language echoing beneath the waves. Octopuses can edit their own genetic code. The octopus drifts through the water like a dream, shape-shifting, color-shifting, watching with eerie, alien eyes. It is already one of the most intelligent creatures on Earth. But what lies beneath is even stranger. Octopuses can edit their own RNA, the molecular scripts that translate DNA into proteins. While most animals stick to the genetic code they were born with, octopuses can make real-time adjustments to how their genes are expressed. They can fine-tune their biology on the fly. We do not fully understand why or how they do this, but it adds one more mystery to a creature that already seems to come from another world. Some animals navigate using the Earth's magnetic field. Every year, birds travel thousands of miles across mountains, oceans, and continents, returning to the same nesting sites with pinpoint precision. Some birds have tiny crystals of magnetite in their beaks or heads, acting like internal compasses. Others may use specialized proteins in their eyes, allowing them to see magnetic fields as patterns or visual cues. Sea turtles use magnetic signatures to return to the beaches where they were born. Salmon find their way from the ocean to the exact stream where they first hatched. Even some insects and bacteria use the field to orient themselves. The earth whispers directions, and life listens. Now let us consider the waters that cover most of our planet. The ocean is stratified into layers like a vast liquid wedding cake. At the surface, the epipelagic zone extends down to about 200 meters. This is where sunlight penetrates, where photosynthesis occurs, where most of the ocean's visible life exists. Below that lies the mesopelagic zone, the twilight layer. Light fades to a dim blue. Strange creatures begin to appear. Fish with bioluminescent lures, squid with enormous eyes. Deeper still, the bathypelagic zone begins, the midnight zone. No light reaches here. Pressure is crushing. Temperatures hover just above freezing. And yet, life persists. Below that, the abyssopelagic zone. And finally, in the deepest trenches, the hadopelagic zone. Named for Hades, the Greek god of the underworld. Each layer is a world unto itself, each with its own inhabitants, its own rules, its own rhythms. The ocean is not one habitat, it is many, stacked on top of each other in the darkness. Some ocean creatures migrate vertically every day. Every night, as darkness falls, billions of small fish, squid, and zooplankton rise from the depths toward the surface to feed. It is the largest migration on Earth, happening every 24 hours. At dawn, they descend again, retreating into the darkness to hide from predators. This diel vertical migration moves more biomass than any other migration pattern on the planet. It mixes nutrients between layers. It transfers carbon from the surface to the deep. The ocean breathes in this rhythm, rising and falling, feeding and hiding, an invisible pulse that connects the sunlit surface to the lightless abyss. Coral reefs are cities built by tiny animals. Each coral is a colony of tiny creatures called polyps. They feed by extending stinging tentacles to catch plankton, and they build their homes by secreting calcium carbonate, creating the stony skeletons that form reefs. Over time, these skeletons accumulate, forming massive underwater structures that can stretch for hundreds of miles. Despite covering less than 1% of the ocean floor, coral reefs support nearly a quarter of all marine life. They are living cities, built not by design, but by the slow labor of millions of unseen architects. Delicate, colorful, and deeply vulnerable. And the coral spawning is one of nature's most spectacular events. On certain nights of the year, under the light of a full moon, corals across entire reefs release their eggs and sperm into the ocean in a synchronized event. The moon's gravity, light, and rhythm cue the corals to act together, increasing the chances of fertilization in the vast sea. For a brief window, the water is filled with drifting life, a snowstorm of new beginnings. In the quiet reef, the moon calls, and life answers. Whales sing across entire oceans. Beneath the surface of the sea, songs drift through the dark. Long, slow, and haunting. The calls of blue whales can travel for thousands of miles underwater. These low-frequency vocalizations are among the loudest and deepest sounds made by any animal. In the quiet depths, they can echo from coast to coast. Whales use these songs to find mates, navigate, and communicate across vast distances. Each population has its own dialect, and their songs can evolve over time, passed down like oral traditions. Some species, like the humpback, create long, intricate melodies that shift year by year. Different whales contributing new phrases. We do not fully understand everything they are saying, but we know it matters. These are not random sounds. They are messages shared across a watery world. The ocean is filled with ancient survivors. Sharks have existed for over 400 million years. Trees, by comparison, only appeared around 350 million years ago. That means sharks were swimming in Earth's oceans before a single leaf shaded the land. They have survived 5 mass extinctions, including the one that wiped out the dinosaurs. Their basic body plan has changed very little over time, a testament to how effective and well adapted they are. Modern sharks come in hundreds of forms, from gentle whale sharks to hammerheads and deep-sea lantern sharks. But all carry the legacy of deep time. Each glide through the water is a movement shaped by eons, silent, steady, and enduring. Horseshoe crabs are even older. They have existed for over 450 million years. Their blue blood contains a substance used to test vaccines and medical equipment for bacterial contamination. Every year, hundreds of thousands of horseshoe crabs are captured, bled, and released. Their blood has saved countless human lives. An ancient creature, still serving, still surviving, still crawling onto beaches, as it has for hundreds of millions of years. Nautiluses are living fossils. These shelled relatives of octopuses and squid have remained virtually unchanged for 500 million years. They were swimming in the oceans before fish had jaws. They rise from the deep each night to hunt, then sink back down at dawn. Creatures of habit cross geological time. Their shells are perfect logarithmic spirals, mathematical beauty encoded in calcium carbonate, grown chamber by chamber as the animal grows. Now let us consider the insects that share our world. Insects outnumber humans by billions to one. For every human on Earth, there are an estimated 200 million insects. They live in every ecosystem, from rainforest canopies to frozen tundra, from desert sands to ocean shores. Beetles alone make up nearly a quarter of all known animal species. Insects pollinate crops, recycle nutrients, break down waste, feed countless other creatures. They have been here for over 400 million years and have survived every extinction event. Their societies can be complex, their adaptations endless. Though small, they are mighty, shaping the world in ways most of us never see. We may rule the land in our own minds, but the insects were here first, and they will likely be here long after we are gone. Bees can understand the concept of zero. In experiments, bees were trained to associate fewer shapes with a sweet reward. When presented with a blank card, no shapes at all, they correctly chose it over cards with one or more. This suggests that bees grasp the abstract idea that none is less than some. Only a few animals, like chimpanzees, dolphins, and parrots, have demonstrated this kind of numerical reasoning. That bees, with their tiny brains, can do the same is remarkable. It hints at a form of intelligence, not limited by brain size, but shaped by need and evolution. Inside a hive, thousands of minds work as one. But even the individual bee holds surprises. Small body, big mind, a quiet buzz, and a brilliant brain. Ants can build bridges out of their own bodies. In the forests of South America, army ants are constantly on the move, flowing across the jungle floor like a living river. But when they reach a gap or obstacle, they do not stop. Instead, they build bridges out of themselves. One ant anchors to a branch. Another climbs onto its back. Then another, and another, until a living structure forms. Flexible and strong. Thousands of ants may link together, adjusting in real time to the weight and traffic above them. When the colony is done crossing, the bridge disassembles, and the ants rejoin the march. These living bridges are not commanded by a leader. They emerge from local decisions, each ant responding to its neighbors, guided by instinct and contact. Fireflies use light to speak. On warm summer nights, the dark comes alive with tiny flashes of light. Fireflies communicate with bioluminescent signals, blinking patterns that vary by species, region, and even gender. Males fly through the air, flashing specific rhythms. Females respond with timed replies from the grass or trees. It is a courtship dialogue, written in light. Some species blink slowly, others rapidly. A few emit a soft, steady glow. Inside their abdomens, fireflies mix chemicals like luciferin and oxygen to create cold, glowing light. The process that produces no heat. It is one of nature's quietest, most enchanting conversations. Termites build mounds with natural air conditioning. From the outside, a termite mound may look like just a pile of dirt. But inside, it is a marvel of natural engineering. A city built by insects. Some mounds stretch over 10 meters tall and house millions of termites in a complex, layered network of chambers and tunnels. The most remarkable feature is the ventilation. Termites design their mounds to regulate temperature and airflow using convection currents. Warm air rises and escapes through vents, while cooler air is drawn in from below. This passive air conditioning maintains a stable internal environment, even when outside temperatures swing wildly. No blueprints, no architects, just instinct, iteration, and cooperation. Now let us return to the forests and the creatures within them. Wolves can reshape entire landscapes. When wolves were reintroduced to Yellowstone National Park in the 1990s, something incredible happened. They did not just affect deer populations, they reshaped the entire ecosystem. With fewer grazing animals, vegetation along riverbanks recovered. Trees and shrubs grew taller, birds returned, beavers built dams. The healthier plant life stabilized the soil, reducing erosion and changing how water flowed. In some places, rivers became more narrow and meandering, more stable. This phenomenon, known as a trophic cascade, shows how a single species can affect an entire ecosystem. Wolves. By simply doing what wolves do, created a ripple effect that transformed forests waterways, and animal populations. In the howl of a returning wolf, the land begins to heal. Trees can recognize their offspring. Research on Douglas fir trees has shown that mother trees can identify their own seedlings among the many plants connected to the mycorrhizal network. They channel more resources to their own offspring. They send them more carbon, more water, more nutrients. This is not conscious thought, but it is recognition, embedded in chemistry, in the slow pulse of sap and sugar moving through fungal threads. A forest is not just a collection of trees competing for light. It is a family, connected by roots, sharing resources, passing knowledge from one generation to the next. The Wood Wide Web is a form of memory. When a tree is attacked by insects, it sends chemical signals through the mycorrhizal network. Other trees, sometimes hundreds of meters away, receive these signals. They respond by producing defensive chemicals before the insects even arrive. Information travels through the forest. Warnings passed from tree to tree, a form of communication we are only beginning to understand. Forest thinks, not as we think, but in its own slow, distributed way. A vast network of awareness spread across miles of roots and fungal threads. Now let us consider the extreme places where life persists. Life can survive in boiling acid pools, in the hostile landscapes of volcanic springs, where temperatures soar and acid sizzles. Life still exists. Extremophiles, microbes that thrive in conditions deadly to most organisms. Some endure heat above boiling. Others survive in pH levels similar to battery acid. They rely on chemosynthesis rather than photosynthesis, drawing energy from sulfur, iron, or other minerals. These microbes may resemble the earliest life on Earth, and perhaps the kind of life we might one day find on other planets. Life finds a foothold in fire, and it whispers to us, wherever conditions allow, life will try. Some organisms can survive the vacuum of space. We have already met the tardigrades, but they are not alone. Certain bacteria and lichens have survived exposure to the conditions of space. The extreme cold, the intense radiation, the complete absence of pressure. They enter dormant states, suspending all biological activity until conditions improve. Some scientists speculate that life might travel between planets on meteors, surviving the journey through space, finding new homes on distant worlds. This idea is called panspermia, and while unproven, it reminds us that life's tenacity may extend beyond the boundaries of Earth. The deepest caves on Earth host unique ecosystems. In the darkness of Mourval Cave in Romania, cut off from the surface, for millions of years, life has evolved in complete isolation. Creatures here have never seen the sun. They survive on bacteria that convert hydrogen sulfide into energy. An ecosystem independent of photosynthesis. Spiders, leeches, water scorpions, all adapted to eternal darkness, all survivors in a world without light. The Earth has hidden worlds beneath its surface. Ecosystems we are only beginning to discover. Now let us consider the strange phenomena of our planet. Lightning strikes the Earth about 100 times every second. That is, over 8 million strikes per day, flashing between clouds and ground, illuminating the atmosphere with brief, brilliant violence. A single bolt of lightning can heat the air to 30,000 degrees Celsius, 5 times hotter than the surface of the sun, for a fraction of a second. Thunder is the sound of that superheated air expanding faster than the speed of sound. A sonic boom created by temperature. Lightning shapes the chemistry of the atmosphere. It creates ozone. It fixes nitrogen into forms that plants can use. It has been doing this for billions of years. The same energy that terrifies us also fertilizes the soil. The storm nourishes the earth. Ball lightning remains unexplained. Witnesses have reported glowing spheres of light ranging from the size of a golf ball to the size of a beach ball floating through the air during thunderstorms. Some last for seconds, others for minutes. Some pass through walls, some explode. Scientists have reproduced phenomena that resemble ball lightning in laboratories. But no one has fully explained the natural phenomenon. It remains one of the mysteries of atmospheric science. A reminder that even something as common as a thunderstorm can hold secrets we do not understand. The Earth hums constantly at a frequency too low for human ears. Known as the Earth's hum, this low-frequency vibration has been detected by seismographs around the world. Its source remained mysterious for decades. We now believe it is caused by ocean waves. As waves collide and transfer energy to the seafloor, they create vibrations that travel through the entire planet. The Earth rings like a bell, constantly, quietly, a note too deep for us to hear. Some deserts sing when sand dunes reach the right conditions. Millions of grains can slide together, creating a deep, resonant hum. It can sound like a cello or a low drone. The phenomenon is called singing sand. It requires specific grain sizes, moisture levels, and wind conditions. When they align, the desert makes music. Ancient travelers reported hearing the sound and attributed it to spirits or supernatural forces. Now we understand the physics, but the wonder remains. The aurora is not the only light show in the sky. There are sprites, red flashes, that occur above thunderstorms, reaching up to 90 kilometers into the atmosphere. They last only milliseconds. There are blue jets, bright blue cones of light that shoot upward from storm clouds. There are elves, expanding rings of light that appear at the base of the ionosphere. These transient luminous events were dismissed as pilot hallucinations for decades. Now we know they are real. Lightning communicating with the edge of space. The atmosphere is stranger than we knew. Rainbows are just the beginning. Under the right conditions, the sky can produce fog bows, moon bows, and even fire rainbows, called circumhorizontal arcs. There are sundogs, bright spots that appear beside the sun when ice crystals refract light. There are light pillars, vertical columns of light that appear when flat ice crystals reflect light from the ground. The atmosphere is an optical laboratory, constantly bending, splitting, and reflecting light into patterns we rarely notice. Now let us consider the cycles that sustain life. The Earth breathes through the carbon cycle. Carbon moves through air, water, plants, animals, and rocks in a slow, interconnected flow. When you breathe out, you release carbon dioxide. Plants take it in during photosynthesis, building leaves, stems, and roots. Animals eat those plants. Decomposers break down what is left. Volcanoes emit it. Oceans absorb it. Some of this carbon becomes fossil fuels. Some become stone, and some lingers in the air. This global exchange helps regulate climate, support life, and shape ecosystems. It moves, not just through years, but through eons. The nitrogen cycle is equally essential. Nitrogen makes up 78% of the atmosphere, but most organisms cannot use it directly. It must be fixed into other forms. Lightning does this naturally. So do certain bacteria that live in the roots of legumes, like peas and beans. These bacteria convert atmospheric nitrogen into ammonia, which plants can absorb. Animals eat the plants. The nitrogen cycles through ecosystems. Eventually, it returns to the atmosphere, completing the loop. The water cycle is the most visible of all. Water evaporates from oceans, lakes, and rivers. It rises into the atmosphere. It condenses into clouds. It falls as rain or snow. It seeps into the ground. It flows through rivers. It returns to the sea. A single water molecule might cycle through the atmosphere dozens of times before settling anywhere for long. The same water dinosaurs drank. The same water that will sustain generations not yet born. Water is never created or destroyed on Earth. It simply moves, endlessly cycling through the planet's systems. Now, let us consider the moon that orbits our world. The moon is slowly drifting away from Earth. Every year, it moves about 3.8 centimeters farther from us. Slowly, imperceptibly. But over billions of years, the effect adds up. When the moon first formed, it was much closer. Perhaps only about 25,000 kilometers away. Today, it is nearly 400,000 kilometers distant. As the moon recedes, Earth's rotation slows. Days grow longer by about 2 milliseconds per century. Eventually, billions of years from now, days will be much longer. The moon will be much farther, and the tides that the moon creates will weaken. The moon stabilizes Earth's axial tilt. The Earth tilts at about 23.5 degrees relative to its orbit. This tilt gives us seasons, summer and winter, long days and short days. Without the moon's gravitational influence, this tilt might wobble chaotically over millions of years, sometimes tipping as much as 90 degrees. Such instability would cause extreme climate shifts, ice ages at the equator, tropics at the poles, a world of constant change. The moon anchors our tilt. It keeps the seasons predictable. It makes our climate stable enough for complex life to evolve. The moon may have played a role in the origin of life. Some scientists theorize that the strong tides created by a closer moon 4 billion years ago may have helped concentrate the chemicals necessary for life. Tidal pools on ancient shores may have been incubators, evaporating and refilling, concentrating organic molecules, creating the conditions for the first self-replicating chemistry. We cannot know for certain, but the moon may be more than a companion in the sky. It may be part of why we exist at all. Now let us wander into the world of rivers and lakes. The Amazon River carries more water than any other river on Earth. At its mouth, it discharges about 200,000 cubic meters of water per second into the Atlantic Ocean. So much fresh water that it dilutes the salinity of the ocean for over 100 miles offshore. The Amazon Basin drains nearly 40% of South America. It passes through the largest rainforest on Earth, and along the way, it sustains millions of species, many still unknown to science. The river itself is home to pink dolphins, piranhas, and the arapaima, one of the largest freshwater fish in the world. In flood season, the Amazon spills over its banks, creating vast flooded forests where fish swim among trees. The Nile is the longest river in the world, stretching over 6,600 kilometers from Central Africa to the Mediterranean Sea. The Nile has shaped human civilization for millennia. Ancient Egypt depended on its annual floods to fertilize the desert and sustain agriculture. Without the Nile, there would have been no pyramids, no pharaohs, no hieroglyphics. Today, the Nile still sustains hundreds of millions of people. But dams have altered its flow. Sediment no longer reaches the delta. The river that built a civilization is now a managed resource. Lake Baikal is the deepest and oldest lake on Earth. Located in Siberia, Russia, it holds about 20% of the world's unfrozen surface freshwater, more than all the Great Lakes of North America combined. The lake is over 25 million years old. It reaches depths of more than 1,600 meters. Its isolation has produced hundreds of species found nowhere else, including the world's only freshwater seal, the Baikal seal. In winter, the lake freezes over, creating transparent ice that reveals the depths below. The Great Lakes contain enough water to cover the entire continental United States to a depth of 3 meters. These 5 interconnected lakes form the largest group of freshwater lakes in the world by total area. They are so large that they create their own weather patterns. Lake Superior is cold enough that bodies do not decompose in its depths. Its waters are so clear you can see down dozens of meters. On calm days, the lakes were carved by glaciers during the last ice age. Now they sustain millions of people and countless species. Underground rivers flow beneath our feet. In the Yucatan Peninsula of Mexico, a vast network of subterranean rivers winds through limestone caves called cenotes. The ancient Maya believed these were entrances to the underworld. Similar systems exist around the world. Water carving through rock over millions of years, creating hidden passages that connect distant springs and sinkholes. Some underground rivers are enormous. The Puerto Princesa subterranean river in the Philippines stretches over 8 kilometers, flowing through a cave system before emptying into the sea. Waterfalls carry billions of tons of water over cliffs each year. Victoria Falls, on the border of Zambia and Zimbabwe, is one of the largest. The local name is Mozio Atunya, meaning the smoke that thunders. The spray can be seen from 30 kilometers away. Niagara Falls moves 6 million cubic feet of water per minute. The falls have been eroding upstream for 12,000 years. One day, they will reach Lake Erie and drain it. Angel Falls in Venezuela is the tallest waterfall in the world. Water drops nearly a kilometer through the air, turning to mist before it reaches the bottom. Now let us consider the deserts that cover a third of the Earth's land surface. The Sahara was once green. Just 6,000 years ago, the Sahara was covered with lakes, rivers, and vegetation. Elephants, hippos, and giraffes roamed the land. Rock paintings in the desert depict swimming scenes, and abundant wildlife. Then the climate shifted. The rains stopped. The lakes dried, and the sand took over. The Sahara will likely become green again. The Earth's orbital wobble brings wet periods, roughly every 20,000 years. In time, the desert may bloom once more. The Atacama Desert in Chile is the driest place on Earth. Some weather stations there have never recorded rain. Scientists use it as a stand-in for Mars, testing equipment designed for planetary exploration. And yet, life persists. Fog rolls in from the Pacific, providing just enough moisture for lichens and specialized plants. Some flowers bloom only once a decade, waiting for the rare rains. Microbes survive in the soil, dormant for centuries, awakening when water finally comes. Deserts are not empty. They are home to remarkable adaptations. Kangaroo rats can survive their entire lives without drinking water, extracting moisture from the seeds they eat. Camels store fat in their humps and can close their nostrils during sandstorms. The fennec fox has enormous ears that radiate heat and detect prey beneath the sand. The sidewinder rattlesnake moves in a unique sideways motion that minimizes contact with the hot ground. Life in the desert is not easy, but it is tenacious, creative, enduring. Now let us consider the polar regions. Antarctica is the coldest, driest, and windiest continent on Earth. The average temperature is about -50 degrees Celsius. Some areas receive less precipitation than the Sahara. Winds can exceed 300 kilometers per hour. And yet, around its edges, life thrives. Penguin colonies number in the hundreds of thousands. Seals bask on ice floes. Whales feed in the nutrient-rich waters. Beneath the ice, liquid lakes exist, isolated for millions of years. Scientists are drilling to find what life, if any, has survived in these hidden waters. The Arctic is not a continent. Unlike Antarctica, the Arctic is an ocean surrounded by land. The North Pole floats on shifting sea ice. Polar bears hunt seals. From this ice, narwhals dive beneath it. Walruses haul out on its edges. But the Arctic is warming faster than anywhere else on Earth. Sea ice is shrinking. Permafrost is thawing. The landscapes that have existed for thousands of years are changing rapidly. permafrost contains ancient secrets. Beneath the frozen ground of the Arctic, perfectly preserved mammoths have been found, their flesh and hair intact after tens of thousands of years. Seeds frozen for 32,000 years have been revived and grown into flowering plants. But the permafrost also holds danger. As it thaws, it releases methane, a potent greenhouse gas. It may release ancient pathogens. It destabilizes the ground, causing buildings and roads to collapse. The frozen past is waking up. Now let us consider the biodiversity that fills our world. The rainforest is the most biodiverse place on Earth. Though tropical rainforests cover less than 2% of the planet's surface, they are home to more than half of all species. A single hectare of rainforest may contain over 600 species of trees, more than all of North America. The canopy is so thick that rain takes 10 minutes to reach the forest floor. Light barely penetrates. Life exists in layers, each with its own inhabitants. We lose about 40,000 square kilometers of rainforest every year. With it, we lose species we have never named, medicines we have never discovered, ecosystems we do not understand. Madagascar is home to species found nowhere else. This island off the coast of Africa has been isolated for nearly 90 million years. Its wildlife evolved in splendid isolation. Lemurs, chameleons, baobab trees, and the aye all exist only on Madagascar. 80% of its species are endemic, meaning they exist nowhere else on the planet. It is a living laboratory of evolution, a window into what happens when life is left alone to diversify. Australia is a continent of ancient survivors and strange evolutions. Cut off from other land masses, for millions of years, Australia developed its own cast of characters. Marsupials, like kangaroos, koalas, and wombats, replaced the placental mammals found elsewhere. The platypus, an egg-laying mammal with a duckbill and venomous spurs, seems almost designed to confuse biologists. Eucalyptus trees dominate the landscape, their oil-rich leaves feeding koalas and fueling bushfires that have shaped the continent for millennia. The Galapagos Islands inspired the theory of evolution. When Charles Darwin visited these isolated volcanic islands, he observed subtle variations between species on different islands. Giant tortoises with different shell shapes, finches with different beak sizes, marine iguanas that swim in the sea. These observations helped Darwin formulate his theory of natural selection. That species change over time, adapting to their environments. That all life is connected through common ancestry. The Galapagos remain a living laboratory, a place where evolution can still be observed in action. Now let us consider the creatures of the deep sea once more. The giant squid was considered a myth until recently. For centuries, sailors told tales of enormous tentacled creatures rising from the deep to attack ships. Scientists dismissed these stories. Then, in 2004, Japanese researchers captured the first photographs of a living giant squid in its natural habitat. It was real. Giant squid can grow to over 12 meters long. They have the largest eyes in the animal kingdom, the size of dinner plates, evolved to see in the dim twilight of the deep. They remain mysterious. We know almost nothing about their behavior, their reproduction, or their lives in the darkness below. The colossal squid is even larger. Found in the waters around Antarctica, the colossal squid has rotating hooks on its tentacles and the largest beak of any cephalopod. We have only examined a handful of specimens, mostly found in the stomachs of sperm whales. The deep ocean still holds secrets. There are likely creatures we have never seen, never named, never imagined. Sperm whales dive to depths of over 2,000 meters. They hold their breath for up to 90 minutes, hunting squid in the crushing darkness. Their clicks are the loudest sounds made by any animal used to echolocate prey. When they dive, their bodies undergo extraordinary changes. Their heart rate slows. Blood is redirected to the brain. Their lungs collapse under pressure. They are the deepest diving mammals on Earth. Champions of the abyss. The vampire squid is neither vampire nor squid. This strange creature lives in the oxygen minimum zone, where most animals cannot survive. It drifts through the dark, collecting detritus with sticky filaments. Its red eyes and webbed arms give it an eerie appearance. When threatened, it inverts its cape, revealing rows of spiny projections meant to startle predators. It is a survivor, an ancient lineage that has persisted in conditions most life cannot tolerate. Now let us consider the forces that connect all life. Everything on Earth is connected. The salmon that swims upstream carries nutrients from the ocean to the forest. When it dies and decomposes, its body feeds the trees. The bird that eats berries and flies to another continent deposits seeds in its droppings. New plants grow far from their parents. The whale that dies and sinks to the ocean floor becomes a feast that sustains deep-sea communities for decades. Nothing exists in isolation. Every organism is part of a web of connections that spans the globe. Mass extinctions have reshaped life on Earth. 5 times in the past 500 million years, life on Earth has come close to total annihilation. The most severe, the Permian-Triassic extinction, wiped out over 90% of all species. The most famous, the Cretaceous-Paleogene extinction, ended the reign of the dinosaurs. Each time, life recovered. New forms emerged to fill the empty niches. Evolution accelerated. The survivors diversified. We may be living through the 6th mass extinction now, caused not by asteroids or volcanoes, but by us. Evolution never stops. Even now, new species are emerging. Old ones are changing. The slow dance of adaptation continues. Bacteria evolve resistance to antibiotics. Insects adapt to pesticides. Urban animals learn to navigate human cities. Evolution does not have a goal. It does not seek perfection. It simply responds to what works here and now. And it will continue long after we are gone. The biosphere is a thin shell of life. All life on Earth exists in a layer just a few kilometers thick. From the deepest ocean trenches to the highest mountain peaks. If the Earth were the size of a basketball, the biosphere would be thinner than a coat of paint. And yet, within that thin shell, life has flourished for nearly 4 billion years. Diversifying into millions of forms. filling every available niche. Transforming the planet itself, we are part of that thin shell, dependent on it, shaped by it, responsible for it. Now let us consider the seasons and rhythms of our world. The Earth's tilt creates the seasons. As the planet orbits the Sun, its axis remains pointed in the same direction. This means that for part of the year, the northern hemisphere leans toward the Sun, receiving more direct light. That is summer. 6 months later, the southern hemisphere has its turn. Winter comes to the north as summer arrives in the south. Without this tilt, there would be no seasons. The equator would always be warmest. The poles would always be coldest. But nothing would change through the year. The tilt creates rhythm. It creates migration. It creates the cycle of growth and dormancy that shapes ecosystems around the world. Seasons affect behavior across the animal kingdom. Birds migrate thousands of kilometers to follow food and warmth. Caribou travel in herds across the tundra. Whales journey from polar waters to tropical breeding grounds. Bears enter hibernation, their heart rates slowing to just a few beats per minute. Squirrels cache nuts for winter. Frogs bury themselves in mud and wait for spring. The changing light triggers hormonal shifts. Animals know when to breed, when to store fat, when to move. They are tuned to the planet's rhythm. Plants measure the length of the day through a process called photoperiodism. Plants can detect how many hours of light they receive. This tells them when to flower, when to drop leaves, when to go dormant. Some plants only bloom when days are long. Others only when days are short. A few require specific sequences of day lengths to trigger flowering. It is a form of timekeeping, a calendar encoded in chemistry. The autumn leaves are a controlled shutdown. As days shorten, deciduous trees begin to withdraw chlorophyll from their leaves. The green fades, revealing the yellows, oranges, and reds that were hidden beneath. The trees are preparing for winter. They will drop their leaves to reduce water loss and avoid damage from frost. Before they let go, they reabsorb as many nutrients as possible. The colors we admire are the last stages of a careful process of recovery. The spring bloom happens earlier every year. As global temperatures rise, plants are blooming sooner. Insects are emerging earlier. Migration patterns are shifting. This creates mismatches. Birds that time their journeys by day length may arrive after the insects they depend on have already emerged. The rhythms that have governed ecosystems for millennia are changing. Life is trying to adapt. Now let us consider the soil beneath our feet. A single handful of soil contains more microorganisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes. A teaspoon of healthy soil may contain billions of microscopic organisms. They decompose organic matter. They release nutrients. They form symbioses with plants. They are the foundation of terrestrial ecosystems. We know more about the surface of Mars than we know about the soil in our gardens. It is a hidden world, teeming with life we cannot see. Earthworms are ecosystem engineers. Charles Darwin spent the last years of his life studying earthworms. He calculated that they could move several tons of soil per acre per year. They burrow through the ground, aerating the soil. They consume organic matter and excrete nutrient-rich castings. They improve drainage and structure. Without earthworms, forests and fields would be less fertile. Crops would grow more slowly. The land would be poorer. Darwin called them the most important creatures in the history of the world. He may not have been exaggerating. Fungi form the largest living organisms on Earth. In the Blue Mountains of Oregon, a honey fungus spans over 9 square kilometers. Its underground network of mycelium connects trees across an entire forest. It is estimated to be over 2,000 years old, perhaps much older, and it is still growing. We see only the mushrooms, the fruiting bodies, that emerge above ground. The true organism lives beneath our feet, spreading silently through the soil. Mycorrhizal networks can transfer nutrients between trees. We have touched on this before, but it bears repeating. Trees are not isolated individuals. They are connected through fungal networks. They share carbon, nitrogen, phosphorus. They send chemical signals. They support their offspring. They may even keep dying trees alive longer than they could survive alone. The forest is a community, an interconnected web of mutual support. Soil takes centuries to form. An inch of topsoil may require 500 years to develop. Longer in some environments. It forms slowly as rocks weather and organic matter accumulates. And yet, we can destroy it in a single season of careless farming. Erosion, compaction, and pollution strip away what took millennia to build. Healthy soil is not a given. It is a treasure, one we too often take for granted. Now let us consider the atmosphere that wraps around our world. The atmosphere has layers. The troposphere extends from the surface to about 12 kilometers. This is where weather happens, where clouds form, where we live. Above that, the stratosphere rises to about 50 kilometers. It contains the ozone layer that protects us from ultraviolet radiation. Higher still, the mesosphere and thermosphere thin into the edge of space. Meteors burn up in the mesosphere. The thermosphere can reach temperatures over 1,000 degrees. Though the air is too thin to feel warm. Beyond that, the exosphere fades into the vacuum of space. Earth's atmosphere has no sharp boundary. It simply thins until it merges with the void. The sky is blue because of scattering. When sunlight enters the atmosphere, it collides with molecules of nitrogen and oxygen. Blue light, with its shorter wavelength, scatters more than other colors. This scattered blue light reaches our eyes from all directions. That is why the sky appears blue during the day. At sunrise and sunset, light travels through more atmosphere. The blue is scattered away. Only the longer wavelengths, reds and oranges, reach our eyes. The sky is a canvas of physics. Clouds are made of trillions of tiny droplets. Each cloud is a collection of water droplets or ice crystals suspended in the air. A single cumulus cloud may contain over 1 billion droplets per cubic meter. Clouds form When moist air rises and cools, the water vapor condenses around tiny particles of dust, pollen, or salt. Different conditions create different clouds. Wispy cirrus clouds form high and cold. Puffy cumulus clouds form in rising thermals. Flat stratus clouds blanket the sky. Clouds regulate temperature. They reflect sunlight back to space. They trap heat from below. They carry water across continents. Without clouds, the planet would be a very different place. The jet stream guides weather patterns. High in the atmosphere, rivers of fast-moving air circle the globe. These jet streams can reach speeds of over 400 kilometers per hour. They steer storms. They influence temperatures. They determine whether a winter will be mild or harsh. When the jet stream dips, cold Arctic air can plunge into temperate regions. When it rises, warmth can extend farther north than usual. Understanding the jet stream is key to understanding weather. And climate change is altering its behavior. Now let us consider the oceans once more. The ocean stores heat. Like a vast battery, water has a high heat capacity. It can absorb and release enormous amounts of energy without changing temperature quickly. This moderates climate. Coastal regions experience milder temperatures than inland areas. The ocean absorbs heat during the day and releases it at night. But the ocean is also absorbing the excess heat trapped by greenhouse gases. Over 90% of the extra heat from global warming has gone into the sea. This has consequences. Coral bleaching, altered currents, rising seas. The ocean is changing, and so is everything that depends on it. Ocean currents are driven by density differences. Cold, salty water is denser than warm, fresh water. This density difference drives the Great Ocean Conveyor Belt, a system of currents that moves water around the globe. Warm surface water flows from the tropics toward the poles. It cools, becomes denser, and sinks. It then flows along the ocean floor back toward the equator, where it warms and rises again. This cycle takes about 1,000 years. A single drop of water may travel around the world before returning to its starting point. The ocean absorbs carbon dioxide. About a quarter of the carbon dioxide released by human activity is absorbed by the ocean. This slows the buildup of greenhouse gases in the atmosphere, but there is a cost. As the ocean absorbs carbon dioxide, it becomes more acidic. This process, called ocean acidification, threatens shellfish, corals, and other marine life. The shells of tiny pteropods are already dissolving in some waters. Coral reefs are struggling to calcify. The chemistry of the sea is changing faster than life can adapt. Seaweed forests are as important as rainforests. Kelp forests along rocky coastlines support thousands of species. They provide shelter, food, and breeding grounds. Like trees on land, kelp captures carbon dioxide and produces oxygen. Dense forests can sequester significant amounts of carbon. Sea urchins, when unchecked by predators like sea otters, can devastate kelp forests, turning them into barren underwater deserts. The balance is delicate. Now let us consider the land and its formations. Mountains are still rising. The Himalayas grow by about 1 centimeter per year. The collision between the Indian and Eurasian plates continues, pushing the peaks ever higher. Mount Everest is not the tallest mountain from base to peak. That distinction belongs to Mauna Kea in Hawaii, most of which lies beneath the sea. But Everest is the highest above sea level, and it is still climbing, still growing, still being shaped by the forces that have operated for millions of years. Caves are sculpted by water and time. Rainwater absorbs carbon dioxide from the air and soil, becoming slightly acidic. This acidic water seeps into limestone, dissolving the rock. Over thousands of years, chambers form, passages connect. Stalactites drip from ceilings. Stalagmites rise from floors. Some caves contain formations that have grown for millions of years. Caves can preserve evidence of ancient climates. Air bubbles trapped in mineral deposits. Layers that record rainfall and temperature. Time capsules locked in stone. Sinkholes can swallow buildings overnight. In areas underlain by limestone, caves can form close to the surface. When the roof of a cave collapses, a sinkhole appears. In Florida, Guatemala, and other regions, sinkholes have swallowed houses, cars, and streets with little warning. They are reminders that the ground beneath our feet is not always solid, that the earth is dynamic, even where it seems still. Islands can appear and disappear. Volcanic islands rise from the sea when undersea eruptions build above the waterline. Surtsey, near Iceland, emerged in 1963 and has been studied ever since. As life slowly colonizes its barren shores, but islands can also disappear. Erosion, rising seas, and subsidence have claimed many over the millennia. Some Pacific islands are already being abandoned as the ocean reclaims them. The earth is always being remade. New land rises, old land sinks. The map is never truly finished. Glaciers carve landscapes. The great ice sheets of the past carved valleys, gouged lakes, and deposited vast quantities of rock and sediment. U-shaped valleys, hanging waterfalls, and cirques are all signatures of glacial activity. The Great Lakes were carved by ice. The fjords of Norway were scraped by glaciers that have since retreated. Today's glaciers continue this work, though most are shrinking. They are rivers of ice, moving slowly, grinding rock, shaping the land. Even now, deltas are built by rivers. Where rivers meet the sea, their flow slows. Sediment drops. Over time, deltas form, extending the land into the water. The Nile Delta, the Mississippi Delta, the Ganges Delta. These are among the most fertile and densely populated places on Earth. But deltas are fragile. They depend on continued sediment supply. When rivers are dammed, the sediment is trapped upstream. The delta begins to erode. The land sinks, the sea advances. Now let us consider the strange and wondrous phenomena of life. Some jellyfish may be immortal. The species Turritopsis doni can revert to an earlier stage of its life cycle when stressed. Instead of dying, it becomes a polyp again and restarts its development. In theory, this process could repeat indefinitely. The jellyfish would never have to die of old age. In practice, predators, disease, and environmental factors still claim them. But the potential for biological immortality exists. A creature that can turn back its own clock. Some animals can regenerate lost body parts. Salamanders can regrow entire limbs. Starfish can regenerate arms. Flatworms can be cut into dozens of pieces, each of which grows into a complete new worm. Some species of sea cucumber expel their internal organs when threatened and regrow them later. Regeneration hints at cellular abilities we do not fully understand. The secrets of regrowth may one day inform medicine. The axolotl remains in its larval form its entire life. This Mexican salamander never undergoes the metamorphosis typical of amphibians. It retains its gills, its fin, its aquatic lifestyle. This phenomenon, called neoteny, means the axolotl reaches sexual maturity without becoming an adult. It is a perpetual juvenile, and it can regenerate almost anything. Limbs, organs, parts of its brain. Scientists study it for clues to healing that we have long since lost. The immortal jellyfish is not the only creature to defy aging. Some tortoises lie for over 200 years without showing signs of age. Their organs do not deteriorate. Their fertility does not decline. The Greenland shark may live for over 400 years. Bowhead whales may reach 200. In these creatures, the usual rules of aging seem suspended. Scientists are searching for the genes and processes that make this possible. Plants can live for thousands of years. The oldest known trees are bristlecone pines in the mountains of California. Some have been alive for nearly 5,000 years. The oldest known clonal organism is a colony of quaking aspens in Utah called Pando. Its root system is estimated to be over 80,000 years old. These ancient organisms have witnessed the rise and fall of civilizations. They were alive when the pyramids were built. They continue to grow as empires crumble. Some organisms never stop growing. Many fish, reptiles, and invertebrates exhibit indeterminate growth. They continue to grow larger throughout their lives. This is why some lobsters, crocodiles, and giant tortoises reach such impressive sizes. They are not bound by the growth limits that constrain mammals and birds. In theory, if nothing killed them, they would keep growing forever. Now let us consider the mysteries that remain. We have only explored a fraction of the ocean floor, despite covering over 70% of the planet's surface. The deep ocean remains largely unexplored. We have better maps of Mars than of our own seabeds. New species are discovered on nearly every deep-sea expedition. Hydrothermal vents, cold seeps, and abyssal plains hold secrets we have barely glimpsed. The ocean is the last great frontier on Earth, and it lies just beneath the waves. We know more about the surface of the moon than we know about the deep biosphere. Beneath the ocean floor and deep within the continental crust, microbes thrive in conditions we once thought impossible. This deep biosphere may contain as much living matter as all life on the surface. These organisms survive on chemical energy, in complete darkness, at crushing pressures. We are only beginning to understand this hidden realm. It may hold clues to the origin of life and the limits of biology. New species are discovered every year. Scientists describe thousands of new species annually, from insects in tropical forests to microbes in hot springs, from fish in the deep sea to fungi in the soil. We have catalogued perhaps 2 million species. Estimates suggest there may be 10 million or more. Most of them are small. Many are microbial. But even among mammals and birds, new species are occasionally found. The inventory of life on Earth is far from complete. The Earth still holds surprises. In the deep caves of Romania, scientists found ecosystems that had been isolated for millions of years. In the Antarctic ice, they found organisms frozen for millennia that could be revived. In the deep ocean, they found hydrothermal vents teeming with life that depends not on the sun, but on the Earth's inner heat. Every expedition brings new discoveries. Every sample reveals new questions. The Earth is not finished revealing itself. We are explorers on our own planet. For all our satellites and sensors, there are places no human has ever seen. For all our knowledge, there are processes we do not understand. For all our technology, we remain students of a world that taught us everything we know. The Earth is patient. It has been here for billions of years. It will be here long after we are gone. And in the meantime, it invites us to learn, to wonder, to explore. The Earth's magnetic field has reversed hundreds of times. Throughout history, the magnetic poles have swapped positions. North became south, south became north. These reversals happen irregularly, sometimes every few 100,000 years, sometimes after millions of years of stability. We are currently in a period of relative stability, but a reversal could begin at any time. During a reversal, the magnetic field weakens. Multiple poles may appear temporarily. Eventually, the field stabilizes in its new orientation. Life has survived every reversal. The transition takes thousands of years, giving time for adaptation. But the weakened field during the transition may increase radiation exposure on the surface. The last reversal happened about 780,000 years ago. The next could happen tomorrow, or in 1,000,000 years. The Earth's orbit changes over time. Our planet's path around the Sun is not fixed. Over tens of thousands of years, the orbit shifts from nearly circular to more elliptical, and back again. The tilt of the axis wobbles. The orientation of the tilt rotates like a spinning top. These Milankovitch cycles affect how much sunlight reaches different parts of the Earth at different times of year. They are one of the key drivers of ice ages. The Earth dances around the Sun in patterns that repeat over millennia. The Sun will not last forever. In about 5 billion years, the Sun will exhaust the hydrogen in its core. It will expand into a red giant, engulfing Mercury and Venus. Earth may survive, but it will be scorched. The oceans will evaporate. The atmosphere will be stripped away. Life as we know it will end. But that is far in the future. So far that it barely registers in human terms. We have time, billions of years of time. And yet the Sun reminds us that nothing lasts forever. Even stars die. Even worlds end. The universe itself has a future we cannot fully imagine. The Earth exists in a vast and ancient cosmos. Stars will continue to form and die for trillions of years. Eventually, even they will cease. The universe may grow cold and dark, or it may end in ways we cannot predict. But here, on this small blue world, life continues. The sun rises and sets. The tides ebb and flow. The seasons turn, and tonight you are here, listening, breathing, part of it all. Now let us consider time. The Earth is 4.5 billion years old. That number is so large, it escapes comprehension. If you compressed all of Earth's history into a single year, starting on January 1st, the first simple life would not appear until late March. Fish would not swim until late November. Dinosaurs would arrive on Christmas Day and vanish the day after. Humans would appear in the final minutes of December 31st. All of recorded human history would fit into the last few seconds of the year. We are new here. The planet is ancient. And yet, the Earth is not the same planet it was 4 billion years ago. It has changed beyond recognition. The atmosphere was once toxic. The oceans were acidic. The continents did not exist. The sun was fainter. The moon was closer. Everything has changed, and everything will continue to change. In about 5 billion years, the sun will exhaust its hydrogen fuel. It will swell into a red giant, expanding beyond the orbit of Mercury, perhaps even beyond Venus. Earth may be consumed, or it may survive, scorched and lifeless, orbiting a dying star. But that is far in the future, so far that it barely matters to us now. What matters is the present, this moment, this breath, this world. Let us now consider our place in it. Humans have been on Earth for about 300,000 years. A blink of the eye in geological time, and yet, in that brief span, we have changed the planet profoundly. We have cleared forests. We have dammed rivers. We have altered the composition of the atmosphere. We have driven countless species to extinction. We have left our mark on every ecosystem on Earth. We are not separate from nature. We are part of it, and we are changing it. But we are also capable of understanding, of wonder, of care. We are the first species on Earth to look up at the stars and ask what they are. The first to dig into the ground and piece together the history of life. The first to understand the forces that shape our world. And perhaps the first to choose what kind of future we want. The Earth does not need us. It existed for billions of years. Before we arrived, it will exist for billions of years. After we are gone. But we need the Earth. And we have the rare privilege of knowing it. Every fact we have explored tonight is a thread in a vast tapestry, a tapestry of time and change and life. A tapestry that connects every creature, every mountain, every drop of water. You are part of that tapestry. The atoms in your body were forged in ancient stars. The water in your cells has cycled through the planet for billions of years. The breath you take now was once breathed by dinosaurs, by trilobites, by the first simple cells that drifted in ancient seas. You are not separate from the earth. You are the earth, become aware of itself. And now, our journey begins to draw to a close. We have wandered through deep time and deep oceans. We have met creatures that glow in the dark and plants that count. We have watched continents drift and mountains rise. We have glimpsed the forces that shape our world and the life that fills it. And yet, we have only scratched the surface. There are wonders we have not touched, mysteries we have not solved, species we have not named, depths we have not explored. The earth is inexhaustible. No matter how much we learn, there is always more. But for now, this is enough. Let the facts settle, like sediment. Let the wonders drift, like clouds. Let your mind grow quiet and still. The earth continues to spin, the mountains continue to rise, the oceans continue to circulate. Life continues to evolve and adapt and persist. And you are here, resting, breathing, part of it all. The same moon that pulls the tides is shining somewhere in the sky. The same stars that forged your atoms are burning in the darkness. The same forces that have shaped the earth for billions of years are working still. You are safe. You are home. You are exactly where you belong. So let the weight of the day dissolve. Let your breathing slow. Let your thoughts grow soft at the edges. The earth will hold you. It always has. Thank you for joining me tonight. I hope these gentle facts about our home have given you something to dream about. There are more wonders waiting, more oceans, more mountains, more mysteries to drift through on quiet evenings. Rest well, and may the earth keep you company through the night. This has been Drowsy Discovery. Good night.